Right. So, in this lesson, we will address one of the fundamental topics in finance, bank loans and the way their payments are structured. I will show you how to perform calculations typically made for you by bank employees. It is a great idea to be prepared before your conversations with bankers, as this will put you in a stronger negotiating position. In addition, you will see how interest rate should be calculated when payments are due monthly. Furthermore, you can distinguish between capital and interest payments, something most people cannot do. We will consider a bank loan that involves constant monthly payments throughout its entire duration. Imagine a person wants to buy a house that costs $300,000. He wants to assess whether this is feasible. After talking to some friends and seeing several mortgage loan advertisements, he concludes the current market rates are between 2% and 4%. So he makes his preliminary calculations by using a 3% rate. Fine. He wants to repay the loan in 10 years by making equal monthly payments throughout this period. Here is the million-dollar question. How much will his fixed monthly payment be for him to extinguish the loan in 10 years? Microsoft Excel can fully answer this question. Let's type the inputs on this sheet. The number of periods during which the loan will be repaid is 120, given that the person will make equal monthly payments for 10 years. The interest rate he will have to pay for borrowing the money is 3% annually. To obtain the monthly interest rate, as usual, one should divide the annual interest rate by 12. This is what we will do here. Okay, very good. And finally, the amount borrowed is $300,000. We have all the inputs that would allow us to calculate the monthly payment for the loan. The Excel formula for this calculation is PMT, as in payment. I will type it in the formula bar and select each input we just entered. Okay, our formula is ready. The borrower must make a monthly payment of $2,896 for 10 years to repay the loan. A heavy monthly expense, right? Let's go a step further and disaggregate what portion of each payment is interest, principal, and how much is the remaining debt. I'll create 5 columns. Period, payment, interest, principal, and residual debt. Okay, the first column will indicate the number of the respective payment. 1, 2, 3, 4, and so on to 120. We already calculated the amount of each of the fixed payments. Here it is. I'll link to the cell and then fix its reference to be able to copy it to the last row of the table. Okay, perfect. Our next task is to disaggregate this payment in 2 parts, interest rate and principal. In the first period, the amount of interest that will be accrued is based on the whole debt that is drawn, and given that no payments have been made, we have $300,000 times the interest rate, which equals $750. The difference between the payment and the amount of interest payments is the amount of principal that is repaid. In the last column, we can calculate the residual debt that remains after this payment. Good. Let's do the same thing on the row below. I'll multiply the interest rate by the residual debt, fixing the cell references of the interest rate. Then I'll take the difference between the payment made and the amount of interest. This is the principal repaid in this period. Okay, let's calculate the amount of residual debt by taking the difference between the amount due before this period and the principal repaid during this period. Here's our residual debt after period 2. We can copy these formulas to the last row of the table. As you can see, the residual debt at the end of the loan life is 0, so we worked correctly. The debt will be repaid after 10 years. This is how we can calculate an entire loan schedule, an exercise that allows us to plan better and understand exactly how much and for what we are paying. Thank you for watching.